the ester synthesis. Okay. So how do we make esters? You guys have seen some reaction in this chapter 20, that acids, reactions of acids. First is the Fischer esterification. Okay, what is Fischer esterification? If you take an acid, okay, I will give you that general structure. If you have an acid like this, okay, and you take an alcohol, and in anhydrous condition, acid catalyst, okay, acid catalyst. Many times, but very little PTSA, paratoluene sulfonic acid. It's a it's a derivative of sulfuric acid type, okay, paratoluene sulfonic acid. So what will happen, easy to remember this one, that OH of acid and H of the alcohol will be gone in the form of water, okay. So it will be RCO and OR plus H2O. Okay, so here we get the ester. So what is the mechanism for this? So see the acid carbonyl is a nucleophile, okay? See here you have lone pairs on the, as 4 lone pairs on 2 oxygen. And you have this acid, paratoluene sulfonic acid. So what will happen? The carbonyl oxygen will get protonated. Okay? And remember, all the reactions are reversible. So it will be RCOH plus OH. Okay? This protonation makes this carbon more electrophilic because of the positive charge on oxygen, which makes the oxygen more electron withdrawing. And another important point, remember here, see, why not this oxygen gets protonated? Only why this one? Anybody can answer? We'll get 2 points. See, you have this lone pair on the OH oxygen as well as carbonyl oxygen, both has 2 lone pairs, but the carbonyl oxygen will get protonated, not the OH. Why? Because of the possibility of resonance in this, okay? Here I can write like this one, positive charge plus OH. And this you can further write one more resonating structure. Okay, if you protonate this one, then there is no chance of resonance. Okay, so this you guys can keep in mind. You can write like this or like that. Okay, so next what happens, alcohol immediately reacts because the carbon become more electrophilic here. Okay, so it's ROH. Okay, so this one. Now the conjugate base can take this proton, it will be removed, and remember again, all these are reversible reactions. So R, so it will be OH, OH, and you'll have OR. So this one of the OHs will be protonated again. Okay. So this from the catalyst, it will be protonated. So you'll have that OOH, OH2. As soon as OH gets protonated, it becomes a very good leaving group. And then the conjugate base will take this proton, and then you'll get the product. Okay, so the conjugate base. So what is the conjugate base here? The conjugate base here is this. Okay, or even the alcohol, another alcohol can take this proton. Okay, so because alcohol is a solvent, so this is the method, this is the Fischer esterification. Another reaction we discussed in the last class, that if you take an acid like benzoic acid, it, because it's an acid, it reacts with bases very quickly. Okay, how? See this one here, like let's say the base is sodium hydroxide. So it's an acid-base reaction. I showed in the last lecture reaction with baking soda and vinegar. So same reaction. So you will have sodium plus minus plus H2O. Okay. So this is here, here the salt here. Okay. So what is this salt? Sodium benzoate. Okay, this is the sodium benzoate salt, like acetate, a carboxylate. Okay, this, and this is a very good nucleophile. So it means it react very easily with electrophiles. So if you take this one and react with an electrophile, let's say here iodomethane, so what will happen? The carbon here is an electrophile, so this will react via SN2 reaction. Okay, and iodine will leave, so here you will get methyl benzoate. It's an ester. So this is one of the methods to make an ester, simple esters, when you use the salt for SN2 reaction. Okay, and another one, so these are simple reactions. Okay, any question? Esters can also be synthesized, like see this acid, when you treat this one with SOCl2, this reaction we have seen previously, SOCl2, what will happen? The OH will be removed and you will get chloride. So here it will be the benzoyl chloride. Okay, so this is a very typical reaction to convert OH, either OH of acid or OH of an alcohol to corresponding chloride. If you want to make bromide, then you have to use PBr3. So benzoyl chloride. This one, when you react with an alcohol again, so CH3, CH2, OH. So this reaction undergoes, this reaction will be nucleophilic acyl substitution. Okay, in the previous chapter we have discussed nucleophilic acyl substitution. Okay, the base is generally taken as pyridine, or any other base will be also helpful that takes this proton. Okay, so what will be the intermediate? The intermediate will be O minus Cl O CH2 CH3. So here the carbon is sp3 hybridized, and the here chlorine is a very good leaving group. Here chlorine leaves, and you get an ester. Okay, so this is the example of nucleophilic acyl substitution. Okay, so three methods, remember, very important. Okay, the previous one, Fischer esterification under acidic condition to make an ester. Second one, via SN2 reaction. Okay, and the third one by using a nucleophilic acyl substitution. Okay. So this is these are very now the reactions of esters. What are the reactions of esters we have discussed? First, we'll talk about reduction. Okay. So what is the reducing agent we have used in previous chapters that came many times? Yes, LiAH4 lithium aluminum hydride. Yes, that is a good. So if you have an ester, let's say this one, you use LiAl, lithium aluminum hydride. What it will make? It will make primary alcohol. Okay. So this is, and this will be also gone in the form of another alcohol. So lithium, what is the another reagent that we discussed previously? Another reagent is dibar H. Okay, dibar. Diisobutyl aluminum hydride. Okay, and that one, if you do at negative 78 degrees Celsius, and we also discussed that how we obtain negative 78 degrees Celsius. How we get negative 78 degrees Celsius? acetone and dry ice. Okay, guys, still you guys need to come to this second test. Okay, don't just forget previous lecture. So acetone and dry ice gives negative 78 degrees Celsius. In that case, it will stop at the aldehyde. So see, this is a very good method. Lithium aluminum hydride, you cannot get an aldehyde. It will always stop by making an alcohol, okay? But diva HK can stop, make an aldehyde from the ester by using low temperature. If you use high temperature like negative 20, negative 10 or 0 degree, then diva H will also reduce aldehyde to an alcohol, okay, if the temperature is higher. So here the temperature is key. Most of the time we don't bother about the temperature of the reaction, but this one for diva H, it is very critical. Okay, so this is the reduction reaction. So just one important reduction reaction. Another is the hydrolysis. Hydrolysis. So esters can be hydrolyzed both under acidic condition as well as basic condition, okay, to an acid. It will be the reverse of the previous reaction. Okay. So reverse of the previous reaction, this one. So under basic condition, let's say lithium hydroxide or sodium hydroxide, what will happen? First, it will make a salt, and then you work up with an acid that will convert this one to an acid. Okay, so this is the hydrolysis reaction. Okay, so this is esters can be hydrolyzed to corresponding acids. Okay, any question? Another important reaction is, okay, reaction of esters with Grignard reagent. The mechanism in detail we have discussed, okay? So I will not go the detailed mechanism. So Grignard reagent, let's say allyl magnesium bromide. So what will happen, this one here, see this is a nucleophile. So I'm not showing the detailed mechanism, and then oxygen will leave, the intermediate will be a ketone. Plus magnesium bromide and OCH3. See, the ketone is also very reactive towards Grignard reagent, so the reaction will not stop here. Okay, so this is further it will react, and after acid workup, it will make a tertiary alcohol. So this we have in chapter, what is this, that chapter? In chapter 17, in the alcohol chapter, we have discussed alcohols and ethers. This is the reaction two alkyl substituents will come in that carbon of ester, and it will make an alcohol. So this is a very important reaction of this Grignard reagent with esters. Okay, so all those reactions you can repeat with cyclic esters. Okay, let's say this one. Okay, what are the cyclic esters? Are called lactone. So cyclic esters, see the same if you use the Grignard reagent here, we did. So what will happen? It will go here, and after this shift on the double bond, the ring will open. So what will make it? O minus. You say this one? Ketone. So again, here you have the acid, and this will make after acid workup, okay, this will be converted to OH, and this will also get converted to OH. So the ring will open, okay. The cyclic esters are called lactone, and there will be all similar types of reactions. So similarly, if you will use lithium aluminum hydride, what will happen? The ring will open and it will be a diol. Okay, and suppose if you have, let's say, this color coded hydrides, okay, then you have hydrogens here, those two, those will take the position of the carbonyl. Similarly, if you have a dibol H, okay, and the H of dibol is like this, then you will have an aldehyde, and the H of the aldehyde will come from the dibol H. So just don't forget the dibol H structure is this. It has only one hydrogen and two isobutyl group. Okay, so this is the dibol H. You can do hydrolysis, you can react with the nucleophiles, and all types of reactions you can do. So these are the reactions of esters. I think all these we have discussed before, so there is nothing new. So you guys can read. And the quiz will be on